All right, so problem number 5. This is going to look a little bit different, which is interesting. Go ahead and give it a try to see if you can draw a resonance structure here. Otherwise, I'm going to continue on. All right, this was really interesting because we don't really have a hint with charges or anything like that. But I see double bonds, so I know that I can draw resonance structures. There are actually a lot of resonance structures I can draw here. It doesn't matter which direction you start with. Just for fun, I'm going to start with this pi bond that's up here. So one thing I can do is I can break the pi bond and give the electrons to the carbon that's on top. There's no particular reason why I picked that one. You could have gone the other way. That's completely fine. And so when I do that, this is what I get. So here, I'm going to keep this double bond because I didn't touch it. If I never touch it, don't change it. I now have a single bond between these two carbons, and because we're in a skeletal form, you really need to remember to check your charges, all right? This carbon lost electrons, all right? We gave those electrons to the top carbon. So my bottom one is going to have a positive charge because it lost, and my top carbon is going to have a negative charge because it gained a lone pair. That is what this arrow is representing that we drew. We broke the pi electrons, we moved the pi electrons by breaking the pi bond and generating a lone pair. So this is one resonance structure I can draw. Notice that I now have a positive charge next to a carbon that has a pi bond. So I know that I could draw another resonance structure where I move that pi bond there. Likewise, I could also just break this double bond if I wanted to, where I put a lone pair right here. And what that gives me is the structure where I have my negative charge, my positive charge. I've now moved these pi electrons to this carbon, meaning that's where my lone pair is. This carbon just lost a bond, so I should have a positive charge here. And that's now my second resonance structures. So I have a lot of charges going on, and I can keep going because now I have a positive charge next to a negative charge. So I could use the lone pair that's implied here to create a pi bond. And so what I get is the following resonance structure, where I now have a double bond here, and my positive charge and negative charges here. So that's really broken down, all right? If you really wanted to break that down into the simplistic one step at a time, that's certainly an option. Another way is I could have gone straight from this structure to this structure, and I'll show you that. So I can start with that original resonance form where I have my two double bonds. I have a pi bond next to a pi bond. That's definitely a pattern telling me there's resonance. If we think about the resonance pattern video from, if you've watched it, this is very similar to that benzene example where I have continuous pi bonds. And so what I can do is, and again, it doesn't matter which direction I go in. I could go from bottom to top or top to bottom. It's going to work just fine. But to get the structure that I drew here, I'm going to start with this lower pi bond, where I'm going to move the pi bond here, and at the same time I'm going to break this pi bond and give those electrons to that top carbon. And so the resonance structure that I get is going to look like this, where I have my negative charge up here, I have my double bond that I formed, and then here's that positive charge. All right? Okay, and again, you could have done this the opposite direction where you started with this pi bond moving down. That would actually be a really cool exercise for you to try on your own and see how what would happen is your charges would be flipped, where your positive charge would be up here and the negative charge would be down here. So that would be a good exercise to try to see if you can get the same resonance structures but with the opposite charges. All right, here's problem number 5.